I'm going to show you a real easy trick today to get rid of buzz and hum problems. It's actually something that's already hardwired into a lot of expensive high gain amplifiers. This cable here is actually a noise gate. You just plug it into your amp's effects loop and it will let your guitar signal pass while blocking any buzz, hum and noise. It's totally passive, meaning you don't need any power to run. I'll show you what I mean. I'll just plug it into this amp here. Just turn it on so you can hear all that noise. I've got the strap behind me plugged into this amp. Now I'm just going to plug this into the effects loop. All gone. I'm going to show you how to build this patch cable today, and then I want to take it a step further and build something with a few more options. But first, let's talk about what's happening and how it all works. So I'm not going to get too detailed here, but inside your amp there are two sections, the preamp and the power amp. The preamp shapes your tone and adds gain, while the power amp basically makes the signal loud enough to hit your speakers. Now the effects loop has been created so you can safely insert effects in between these two stages inside your amplifier. So why does that even matter? Well, if your overdrive or distortion is primarily coming from your amplifier, like if you're using your amp's overdrive or distortion channel, then inserting effects like reverbs or delays into that effects loop will make them act and sound how you'd expect them to, as opposed to directly plugging them into the amp's input jack. Now that same spot right in between the preamp and power amp stages is perfect for a noise gate because a lot of noise is amplified by that preamp stage. So all you need is a patch cable and a couple of 1-cent diodes, and we're going to be running these in series with the signal. Super easy. So I want to explain how this works in a more practical way, because that's how I tend to think about things, and I think it's a lot easier for everyone to sort of understand. So a diode acts kind of like a one-way valve for audio. So once the audio hits that diode and reaches a certain threshold, the diode opens and lets your signal through. So it's letting that signal through, but it's blocking everything else below that threshold. The diode we're going to be using today is a 1N4148 silicon diode. It's a pretty common diode, and it has a threshold of 0.6 volts. So once your signal reaches that 0.6 volts or is loud enough to break that threshold, it lets that signal through and it's going to block any of that buzz and noise that is below that. First, what you need is a old patch cable. Just go through your bin of cables. I'm sure you'll find something in there. Here's one I definitely didn't make 5 minutes ago. Next, you're going to need two of these diodes. Now, these are a 1N4148 diode, a silicon diode. Pretty common. Any silicon diode will work just fine. Okay, so we need these diodes to be back to back, facing opposite directions. So they've got a black band on them, and that shows the cathode side or the output side of the diode. So you're going to hold them back to back. So I've got one diode going this way, one facing this way. Then I'm going to hold them and twist the legs together. And it should kind of look like that. Now I've got each diode facing in opposite directions. So now we've just got to solder it into this cable here. Right, so I've unscrewed one of these ends, and here is our hot lead right here, this one. That's our hot lead, the one going to the tip. So you're going to get your little diode arrangement. We're just going to clip it, and I'm going to tin those ends. So tinning just means I'm running solder onto those ends. Right, now I'm going to remove this center, the hot wire there. Now I'm going to cut that back a little bit. Right, now I'm going to tin those exposed wires. Get a bit of solder on there. Now I'm going to join one side. It doesn't matter which way it goes around, just one side of this little diode package is going to go to the hot lug, and the other side is going to connect to that cable. So you can see here I've connected from the center wire of my patch cable through these diodes to the hot lug on this jack. So that's the tip. If I spin it here, that's what it looks like. But there's a little bit of a problem. I don't really like that that's kind of close to that ground there, so I'm just going to put a bit of insulation tape. Normally I like using heat shrink, but it's a little awkward to use heat shrink in this situation, so let's just pop that on now. I've just wrapped a little bit of insulation tape around there just in case, but you know, it's really unlikely anything's going to happen there. Now it is time to test this out. Right, so let's screw this end back on. So I've got my multimeter here, and I'm going to put it on diode test mode. So I want to make sure that I'm getting a diode reading of about 0.6 volts in either direction. So I'm going to put, there we go, yep, pretty much bang on 0.6. Then I flip them around, I should get the same, and nothing between ground and the tip. Perfect. So now I will try it in the amp itself. Okay, it's time to test this cable out. Now if you are going to build one of these, please keep watching. There's a little more information you need to know first before tackling this. Okay, we're all plugged in. This is the amount of noise I've got at the moment. Hear that noise there? Right, let's plug in that cable. Obviously a massive noise reduction there, but we can still play our guitar like normal. So to take this a step further, I built this box. Now this has a bypass switch along with 2 selectable threshold levels, and it just makes it a little bit more versatile, still all without needing any power. Plus, members, the schematic for this box is free on my website, and if you want to support the channel, I've got links in the description to the schematic over there as well. Also, there is a free section which I'm adding to all the time, so make sure you go over there and just download all the free stuff. Okay, so here's how the box works. At the moment, the box is in bypass. I'm using a fairly gained up sound, so it sort of emphasizes all that noise and buzz. Right, so I flick it to the standard setting, and you can hear it's attenuated a lot of that noise, but quite a lot of it is still there. So I've got an extra threshold that sort of drops that noise level even more so. So now it's almost inaudible, and there's quite a lot of gain going on there. Okay, there's one more thing you need to know before building this box or building that patch cable, is that it creates a little bit of crossover distortion. Now this can be a deal breaker for some depending on your tone, and that's a big reason why you find it a lot in high gain amplifiers, because all that gain does mask that crossover distortion really well. Let me show you. Okay, I've got a clean sound at the moment. Okay, let's add that first layer. Can you hear how it's a little bit more distorted? It might be something you really like some people really like that sound. Now turn it off. And if I put it on the really heavy setting, it'll be super obvious because there's actually not quite enough signal to really break through that barrier. Well, if you think of your guitar signal as an AC waveform swinging above and below 0 volts, so when the signal is below the threshold, which is 0.6 volts for these silicon diodes, neither diode conduct and the signal is blocked. But once the signal exceeds the threshold, the appropriate diode turns on and lets its half of the waveform pass. Right at that moment when one diode is turning off and the other one is turning on, that's when it creates that crossover distortion, and that's what you're hearing there. That's what that sound is. If we crank the gain up heaps, if we're pushing hard enough through, you won't notice it as much. If I turn that off. How I got the extra setting in that box is I just added diodes in series. So I'm using more diodes in series to create a higher threshold that needs to be broken before it lets that signal through. But you could even apply this to your pedal board if you use diodes with like a really low forward voltage. Some even go down to 0.2 volts. So that would actually be quite a fun experiment, something I might try a bit later on. I hope you guys enjoyed this video today and got something out of it. Definitely give it a crack. If you've got the right sort of setup and the right sort of sound, you're going to actually really love this. It works so well. Anyway, guys, have a great week.